Review question 4, class notes and textbook is what I used. Oh my god, so sorry. That's just my foot. I am so sore. First question is asking how P21 regulates the cell cycle. So it basically slows down the cell cycle and it inhibits CDK or any kinase activity. And what that does is when it inhibits kinase activity, it basically just leads to growth arrest in a specific cell cycle, which can be very beneficial to that cell cycle. So say we have a CDK and we have a cyclin. This would be an active state if this was the CDK and that was the cyclin. And for it to be inactive, we need the cap to come in, which would be P21. It would come in and it would make this whole thing inactive. It can also be inactive if the cyclin isn't bound to the CDK. So estrogen and P21, what is the relationship? So I'm going to draw a promoter, and I can explain it to you better as I do that. So we have the Tata box. Wow. And then I'm just going to write ERE, but it's the ERE and /APC 1. Complex. Oh my god, I'm so sorry. I don't know what that is. That's wild. Okay. So basically this is the gene, the P21 gene. So what happens is this is the estrogen response element, and then the APC is the anaphase promoting complex. So basically what happens is estrogen regulates transcription, or at least the ERE alpha does. It regulates transcription. So, in order for this cell to go through transcription, it needs RNA polymerase with its transcription factors, and then it also needs the estrogen to bind to it. And what that basically looks like is it's the ER alpha, which is the binding complex, and then the estrogen is the E2, and that comes in, and that estrogen binds to the receptor, basically making a homodimer. So yeah, like I said, P21 slow cell cycle down. The estrogen is needed for the transcription to occur for this cell, so that way it can slow the cell cycle down. And if there is no estrogen, it's just not gonna happen. It's not gonna happen. What do I feel like I'm forgetting? Estrogen, P20. No, I don't think I'm forgetting anything. Oh my god, please don't shut off. Okay. So, I'm gonna move it so I can actually. Right. So, Maui, what are you doing? What are you doing? Stay over there, please. There you go. Hi. Hello, baby. Okay. So, I don't even know what to call this. Is it like the estrogen pathway? The endocrine pathway? It's part of the endocrine pathway, but it's like how estrogen, like, Maui, what are you doing, buddy? He wants to learn, apparently, just as much as I do. Okay, so I'm just gonna call it the endocrine estrogen pathway. We're gonna go for it. I believe it'll be relevant. I'm just gonna write it so I can figure out where to connect it to. So, the first one. Okay, I'm gonna draw a cell membrane. Okay, that's a cell membrane. So the estrogen is going to diffuse through the it's gonna, oh my god, it's gonna diffuse through the membrane, I believe the plasma membrane and the nuclear membrane. So then after it does that, there is gonna be like a receptor. We're gonna make it look like this. Beautiful. There's gonna be a receptor. So then the estrogen is gonna bind to the receptor, and like we said before, the receptor is the ERE alpha. So the estrogen is going to bind to this receptor in the nucleus, And then the ER alpha is going to dimerize it. And what that basically does is it basically turns into like a homodimer, which a homodimer just means that it's the same thing, the same receptor. Sorry, I don't know what that was. The same receptor. So then, the ERE alpha and then the E2 are going to bind to the promoter. Work with me here. And I don't feel like writing it out. But the promoter was just basically that thing that where the ERE complex was. That's the promoter. And yeah, and it can activate transcription. It can increase it or it can decrease it. So this is relevant because if estrogen is going to increase the proliferation of the mammary gland, it's either, oh my god, please don't shut off. It's going to need to increase or decrease. But most likely you want it to increase transcription, and in order to do that, it needs to go through all of those steps. So that way, when it does bind to the promoter, it can help regulate that transcription and inevitably, hopefully, increase it so that way the proliferation of the mammary gland will increase. Because, for example, if we're using the P21 gene to slow the cell cycle, that can help it, because if the cell cycle is slowed down, that means that there's not going to be as much like G1 phase, S phase, the growth phases, G1, G2, the synthesizing phase, the S phase, and then mitosis. That's going to be slowed down, so that way there's not as much going on there, not as much splitting and dividing, which is a good thing, because if you want it to proliferate, then you would most likely want the transcription to be increased for a gene that codes for slowing of the cell cycle. And yeah, I think that is all I have to say for that. I hope it's right. Good night. I will see you in the morning.